Bismillahirrahmanirrahim. Assalamualaikum everyone. Well, now we are going to continue chapter 5, subtopic 3, which is infrared spectroscopy. And before this, we already discussed about chapter 5.1, X-ray diffraction, and 5.2, SEM, scanning electron microscope. SEM. Now we are going to discuss about infrared spectroscopy. What is infrared spectroscopy? Infrared spectroscopy, or IR spectroscopy, is the spectroscopy that deals with the infrared region of the electromagnetic spectrum, that is light with a longer wavelength and lower frequency than visible light. It covers a range of techniques, mostly based on absorption spectroscopy. As well as with all spectroscopy techniques, it can be used to identify and study chemical. A common laboratory instrument that uses this technique is a Fourier transform infrared FTIR spectrometer. FTIR, Fourier transform infrared spectroscopy, is a technique which is used to obtain an infrared spectrum of absorption, emission, photoconductivity or Raman scattering of a solid, liquid or gas. And FTIR spectrometer simultaneously collects spectral data in a wide spectral range. The term Fourier transform infrared spectroscopy originates from the fact that a Fourier transforms, a mathematical process, is required to convert the raw data into the actual spectrum. The component of FTIR spectrometer. The main component, spectrometer, consists of a source, interferometer, sample compartment, detector, amplifier, A and D converter, and a computer. The source generates radiation which pass the sample through the interferometer and reach the detector. Then the signal is amplified and converted to digital signal by the amplifier and analog to digital converter respectively. Eventually, the signal is transferred to a computer in which Fourier transform is carried out. Figure below is the block diagram of a FTIR spectrometer. Okay, here's a source of the infrared produced, and they will go through the collimator, okay, to guide the FTIR light, okay, and then they will pass through the beam splitter, okay, and some of them go to the sample compartment, okay, and they have the detector, and some are going to the moving mirror and fixed mirror, okay. The goal of any absorption spectroscopy is to measure how well a sample absorbs light at each wavelength, which is they will produce much range of the wavelength, and the most straightforward way to do this is to shine a monochromatic light beam at a sample, measure how much of the light is absorbed, and repeat for each different wavelength. Okay. FTIR technique shines a beam containing many frequencies of light at once and measure how much of that beam is absorbed by the sample. The beam described above is generated by starting with broadband light source 1 containing the full spectrum of wavelength to be measured. The light shines into the Michelson interferometer, a certain configuration of mirrors, one of which is moved by a motor. As this mirror moves, each wavelength of light in the beam is periodically blocked, transmitted and blocked and transmitted by the interferometer due to wave interference. Different wavelengths are modulated at a different rate so that At each moment, the beam coming out of the interferometer has a different spectrum. Okay, the function is to the filter and allow a certain wavelength with the various wavelength to test the sample if the sample is absorbed or not. Computer processing is required to turn the raw data light absorption for each mirror position into the result of light absorption for each wavelength. Okay, they have a raw data and raw data of the absorption, okay, for each wavelength. The process is required a common algorithm called the Fourier transform. That's why they call the Fourier transform. They are using the maths equation. The raw data is sometimes called an interferogram. Okay, so they will study about the result from the mirror position and the scan. In FTIR is failure analysis technique that provide information about the chemical bonding or molecular structure of material, whether organic or inorganic. It is used in failure analysis to identify unknown material present in a specimen and is usually conducted to complement energy dispersed X-ray EDS analysis. Unlike SEM inspection or EDS analysis, FTIR spectroscopy does not require a vacuum condition since neither oxygen or nitrogen absorb infrared rays. FTIR analysis can be applied to minute quantities of material, whether solid, liquid, or gases. Okay, this is example of a scan of FTIR spectrum plot. Okay, so you can see here the transmittance, percent of the transmittance, and they got absorbed at the wavelength of wave number 3000 wave number, and a part of the wavelength numbers also have absorbed. Okay, they have all data, this data. Okay, that's all. Okay, thank you. Bye. Assalamualaikum warahmatullahi wabarakatuh.